Hello everyone. I'm going to give you offer related to CCI lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have SD-WAN full-fledged lab. Actually, this is complete CCI enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in CCI exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular EveNG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SD-WAN, you need to work on vEdges and the vManage. Release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCI exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA because in this EveNG lab, we don't have Cisco DNAC integration, and you can't do ICE lab as well because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCI exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCI exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCI exam. So what is the cost of this? Because I'm offering this for the students, so I put very little a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request. Let me write here, Ratnesh721 Kumar 721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EveNG software, or the file where you can go and practice your CCNA, CCNP, CCI, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCI, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, in CCNP, again, we know that we have N core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market so you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching. Thanks for joining. Today we are in day 5 and today's topic is quality of service. So let's start. And do you know what is quality of service and why we are using?
Yeah, QoS is network traffic control mechanism um, that is used to like ensure that like um, applications that are critical on the network um, have, you know, um, like good bandwidth to run, whilst others that are less preferred, are limited. Their capacity on the network is limited. So it's that's a mechanism that lets you, regulate how traffic, for you to prioritize certain um, prioritize traffic for certain applications.
Right. That is perfectly correct statement, definition. And if I ask you that what type of QoS we have, means can you apply QoS in LAN and can you apply QoS in WAN as well?
Um,
Yes.
I mean,
Apply
yes,
Q.
yeah, go ahead. Go ahead.
Yes, you can apply QoS in LAN, and then you can apply it in data center during the one.
When we are applying QoS in WAN, at that time, obviously we know that the WAN links are slow compared to LAN. So LAN may be 1 gig, 10 gig, but WAN may be 1 gig or 100 Mbps or 500 Mbps. That means that when we are applying QoS to WAN, at that time, we have some sort of fast sender, slow receiver. So what I'm telling, suppose if we have two WAN router, in between these two WAN routers, if we have ISP in between, and then if we are applying QoS, so we are applying QoS on different interfaces. Suppose we are applying QoS on this particular interface and this particular interface. So at that time, we know that the QoS that we are applying, it is applicable over the WAN interface, means this QoS is applicable over this particular interface in between this to this, something like that, like here in this section and this section. So we know that the link speed at this interface is slow, and that's why we are applying QoS. But furthermore, if suppose if we have LAN switches connected with this particular WAN router, so if I go and draw the link in between the here and here, so in that case we can go and apply QoS over these interfaces as well, like this interface, this interface, this interface, this interface. We are telling, so if I put marks here, means numbers here, so suppose this is 1 and this is also 1 and this is 2 and this is also 2 and this is 3 and this is 3. So you are telling that we can go and apply QoS over number 1, over number 2 and over number 3 as well. Is that correct statement? Yeah, question to you. So you can apply to all these interfaces, right? So that means one thing is for sure, that when we are using QoS, quality of service doesn't mean that all the time we are applying quality of service QoS for better utilization of bandwidth. Sometimes these QoS will provide you some other features as well. That is irrespective of bandwidth speed, right?
Yeah.
So what is that feature?
Um, it's just like traffic shaping in the environment, just to, you know, not necessarily bandwidth optimization, but in terms of um, you know, shaping the traffic so that some traffic are preferred than others.
Okay. So you're telling
Is
that
that not what
traffic,
QoS is supposed to do?
yeah, traffic
Mm-hmm,
shaping. Suppose if I go here and connect some
mm-hmm,
IP phones.
mm-hmm,
Suppose you have IP phone connected, suppose you have some video conference going on, suppose you have telepresence going
mm-hmm,
on, suppose you have other business
mm-hmm,
applications going on like SAP or any type of critical
mm-hmm,
business applications. So suppose if you have 3 or 4
mm-hmm,
different type of business traffic,
mm-hmm,
right?
mm-hmm,
That is going below
mm-hmm,
the switch that is connected with some LAN core or LAN switch. So at that time,
mm-hmm,
what you want to do with QoS? So in that particular case scenario, you are doing something called traffic classification and marking.
classification, yeah, yeah.
Right? So you are doing the classification such as critical, non-critical, VoIP, telepresence,
Mm-hmm,
bulk data, junk traffic like that, relevant,
mm-hmm,
irrelevant applications. And then if you have some um, low latency type of traffic, we are going to see all these things. If you have
mm-hmm,
some traffic which need less loss jitter, in that case, even you can go and put some DSCP marking as well. Differential service code point, or maybe you heard about this CoS, class of service, TOS type of service. These type of bit marking bit that we are assigning to do classification and marking. So one use of quality of service is that you are doing classification and marking,
okay.
right? So when we are studying this QoS, QoS is all logical. If you go and think about your network, and inside that network, what type of requirements you have, according to that, you can go and learn this QoS. So one thing is classification and marking, C and M. One other thing you pointed out here is the shaping, right? You told
Mm-hmm,
earlier shaping. Shaping and policing.
mm-hmm,
Oops. Shaping and policing is one other thing. Okay. Okay. And then what other mechanism we have in QoS? You think like that. You think like a classical case of ambulance. So normal traffic is going on, and then ambulance is coming. So everyone is giving no pass to ambulance to go. Why? Because they have some priority defined. So there may be some traffic which has some sort of priority.
mm-hmm,
So you can go and define the priority for that traffic. Those may be VoIP related traffic, voice related traffic. Those may be some video conferencing,
mm-hmm,
right? So you can go and define the priority. You can do buffering in case of shipping, policing. You can go and do the classification and marking. Like that, there are different type of mechanisms that we are applying with QoS. Now, once we know all these mechanisms that QoS can do this, QoS can do this, QoS can do this, QoS can do this, all those terms, then The very important understanding about QoS is this. Suppose if we are applying this to Cisco hardware, so where you will apply, right? So this QoS, again, further you can divide in two parts. One is hardware QoS, one is software QoS. Now, what's the difference between hardware QoS and software QoS? Henny, can you tell that what is the difference between hardware based QoS and software based QoS?
That is the software is where you configure the whole thing to tell it what you know in terms of utilization of the traffic. And then the hardware is like having the equipment like load balancers, and that's how I understand it. Yeah.
Yeah, so software means that you can do some sort of programming, coding, some sort of things, right?
Yeah.
Hardware means that is something related to line rate. Something which is in hardware, it has to deliver. Software, you can put some sort of load balancing, class based weighted, fair QoS, low latency queue, whatever logic. Whenever you are applying any type of logic, those logics are applicable to software only. Once it is in hardware, it has to deliver. So if something is there in the hardware, you can't do much. What you can do, maybe you can do some sort of shaping or prioritization, but you can't do much programming, because in that case, you have to go and program the hardware or the line cards. So hardware, the example for this hardware is that if you go and study QoS, you will find that QoS may be applicable at two positions. So suppose this is a router, you can go and apply to the ingress. Means traffic is coming, hitting to the router. So you can go and apply to this interface, and then traffic is leaving that router or switch. So you can apply to the egress. Egress means now it is ready to go to the wire. So this point, this will be hardware QoS. And when the traffic is coming hitting to the router, it will be software QoS, because here you can go and apply some rules, right? You think whatever rule you are applying, where you will apply. If you are doing some programming, something, you have to go and do to the ingress direction, not in the egress direction. Now, egress direction also you can do something. We'll see that, how we can go and do. Up to this point, it's okay, right? You understood everything.
No, I mean, so if you're using coding or you're using commands, then you do it on the ingress interface, like the interface hitting the router.
Yeah.
And then if you're doing if you're using a hardware component, then so you still have to do configuration on the egress.
Yeah. So I'll explain, you will understand this.
Yeah, it's a little confusing.
Yeah. And we have lab as well, so you will understand. Now, this is actually very important point that we are going to discuss now. So let's focus on this. Suppose I have one router here, and then this router is going to connect with ISP. Suppose this is ISP cloud. And then this router is connected with LAN. So this is LAN link. And this is one switch here. Now, I want to go and apply QoS on this interface. And then I want to go and apply QoS to this interface in two directions. So the point here is this, that when you are applying the QoS in the WAN facing interface here, and you will see that later on. The best practice is this, that simply we are going to this interface. So we have interface here, simply we'll go to this particular interface and then we'll apply the QoS. We'll not put the direction here. So that means the traffic that will go and hit on this particular interface, that means the incoming traffic. Here you can go and apply all the software, hardware, QoS, whatever, everything is applicable. But when the traffic is going from here to the wire, here you can't apply everything. So there is limitation that what type of policy you are applying here. So that's why if you have one policy applying in two direction, we have to create such type of policy which is applicable in both the directions. Got it?
Yeah.
Anyways, I'm recording. You can check the recording as well. So now when we are applying QoS here you will see that I think maybe 99% of time we are applying policy in the inward direction, in direction.
Okay.
We'll see that one live example. Actually in SD-WAN we have this QoS topic, full-fledged 1 hour QoS with configuration. So there also you will understand more when we'll do the lab. So in the LAN side, this is what LAN facing QoS. So in the LAN facing direction, we are applying in the in direction. And in WAN facing, we are applying in both in and out. That's the best practices, Cisco best practices. Okay, so knowing these many things, let's go and check what we have in the slide. These slides.
So in and out, does it mean it's going to be on a global configuration?
Global configuration, 100% right. So over the interface, you are applying it. Because you will apply to interface, right?
Yeah.
So whatever interface we have, suppose this is gig 00. So we'll go to gig 00 and we will apply QoS. If we have DMVPN tunnel, for example, this is DMVPN hub, and then we have DMVPN spokes, then in that case, we can go and apply over the tunnel interface. Okay. All right, so let's go back and let's go continue and check the slides we have. Now we'll see most of the things you will understand. So when we are talking about QoS, QoS doesn't mean that all the time you are talking about congestion. All the time you have lack of bandwidth and you are applying the QoS. This is not the correct statement. QoS we are applying not only for bandwidth management, but for traffic management as well. Traffic classification and management as well. So here you can see that different type of QoS we have: classification and marking. So you will classify this is VoIP traffic, this is bulk traffic, this is business traffic, this is irrelevant, this is relevant traffic. Like that you can do the classification and marking for the traffic. Then you can go and provide different type of QoS enhancement mechanism, such as what you can see that congestion management, that is one of the thing, such as giving the prioritization to the traffic, such as you can see here as well, scheduling. The different type of drops are there, like tail drop or weighted or early random detection, etc., etc. We'll see that one by one. But the point here is this, that QoS is not only to provide you optimum bandwidth. QoS has different type of features as well related to different class of traffic. Okay, now we know this thing and we can go and configure QoS and apply to the interface. But very important thing. So suppose if I have one router and this particular router, the very, very important thing about QoS is this. Because Cisco, what they have done, so whenever Cisco is seeing that, okay, this company has this type of router, this is good, so they are acquiring that particular company. So Cisco has acquired Nexus brand, Cisco has acquired Viptela, Cisco has acquired Catalyst Switch, Cisco has acquired different router companies, and then they are rebranding that particular company as Cisco company, and then they are Cisco routers. So you have different type of hardware like ASR, ISR, Nexus, Viptela, ISR 1000, etc. So very big product line is there. Now, when we are talking about this big product line, this particular big product line, all these hardware. So for example, Catalyst 3850. This hardware structure is different than Catalyst 9000, right? So if hardware will be different, QoS will be also different. So QoS structure, QoS hardware in Nexus is different than QoS in routers or switches. So if QoS is different, means QoS hardware is different, that means that the way you will go and apply the QoS is also different. And that's right. If it is a software command or configuration, so that may be common for all the, for example, iOS XE operating system. So you can go and apply iOS XE QoS based configuration to all the iOS XE software, right? But this iOS XE may be used by 3850, may be used by Catalyst 9000, may be used by some other routers as well. Their hardware is different. So one very difficult uh, thing we have in QoS to learn and become master is that different hardware components. Software, okay, you can go and configure same type of configuration everywhere. But if you go and check some old switches like 2960, so their QoS configuration is very different than 3850. Nowadays, Cisco has tried to unify this operating system, so that's why you have unified type of configuration. But still, if in your infra you have different type of hardware, you will see that QoS configuration is different. Okay, so now because we have different types of hardware, the configuration is different. So in that case, what we have to do, or we are doing, that in that case we are creating the configuration, we are doing the classification and marking, and then that particular configuration we are mapping with queue. So this is termed as a queue. Queue means hardware queue. You will see that in Cisco SD-WAN Viptela, we have, for example, 8 different queue. So starting from queue number 0, so suppose I have Q0, Q1, this is hardware queue, up to queue number 7. That means total 8 queue, right? So Q0 and 1, they are for control plane traffic, or they are for a very critical business traffic or voice related traffic. You can think as a VoIP related traffic. And then from queue number 2 to queue number maybe 4, you can reserve for business critical applications. Then 5, 6, 7 you can use for less priority traffic. Generally, you will see that companies, for sake of simplicity, they are dividing their traffic in 3 different category. One is high priority traffic, then mid priority traffic, and low priority traffic. And then that high, mid, and low priority traffic, they are mapping with different type of queue. So suppose nowadays you can see that we have 2 version of routers or switches, right? You have hardware based, you have software based. Now if you have virtual routers or switches, in that case you have only 4 queue: Q0, Q1, Q2, and Q3. So in that case, you can go and apply, suppose Q0 is reserved for control traffic or network traffic. So high priority traffic you can map with Q1, mid with Q2, and Q3 with low priority traffic. Why we are doing this mapping? Because if you reserve your traffic for high priority traffic or higher queue, that means that there is less tail drop. If traffic is getting dropped, so in these queues, the chances that traffic, because they have some priority, so the chances of getting dropped will be less rather than in Q3, you have that chance it can be dropped because this is low priority traffic. Till this point, if you have any question, please ask. Okay, no question, then very good. We have covered only 20 to 25 minutes, just 1 or 2 slides, but I will request you to go and watch this recording one more time because we are discussing very, very important points. These are very important points related to QoS. After this class, you can go and watch any QoS video or you can read any document, you will understand. Okay, so this is very important. Now we have 4 or 5 more slides to understand whatever we have discussed earlier. So now you can see now how good this particular slide is. Even for design perspective, you will see that clearly it is telling that, okay, you have voice related traffic, you have video conference traffic, you have telepresence traffic, you have data traffic. Now all these different traffic in blue, orange, red, and violet, all these different color marking and traffic, we can go and do the classification and marking. Now we will see the nature of the traffic as well and the latency and jitter criteria as well. So voice related traffic, it should be delivered within 150 milliseconds, otherwise it will get expired. Like the logic of that particular packet will get lost. It's like that. It should be delivered within 150 milliseconds. Likewise, the video conf traffic, but telepresence has latency of 200 milliseconds. Now, data traffic that you can see, since this data traffic using, using TCP retransmits, that means that if any congestion is there, traffic drop is there, that means that particular server or client, they have to reinitiate the TCP transmits. And if you have too much congestion, if you have too much delay, in that case, you will see if you go and do the packet capture with Wireshark, you will see in that capture, you will get too many retransmits packet, right? So according to the nature that we have for loss latency jitter, you can see the bandwidth as well. Cisco is suggesting the bandwidth criteria as well. So according to this loss latency and jitter parameters, we should go right and give the priority in the hardware queue. Because when the traffic is in the wire, at that time you have to make sure it should be delivered within 150 milliseconds, within 200 milliseconds and all. Right. So this is nothing but you can go and check the nature of traffic. According to that, you can go and do the classification of the traffic. Now let's see the example here. Now this is the software based configuration. You can think this as iOS XE based configuration. And in this configuration, you will see that we have classical configuration related to voice. So what we are doing, so first of all, the policy name is WAN. Then we have classes. So class is voice. We are giving priority 10%. Again, for class video, we are giving priority of 23%. Then critical data, 15%. And then random detect. Random detect means I will explain you what does it mean. Then you will see this data field. And then you can see this scavenger traffic, which is we are giving very less bandwidth percentage for that. Then you can see this class network critical. Then we have service policy. Then we have default policy. So you can see clearly that the policy that we are creating here, this entire policy, it is over global configuration. So you have created the policy. That doesn't mean that we have applied this policy. We have to go to the WAN interface because policy name is WAN, and then we have to apply this in or out.
Okay, so I got a
Yep.
question. So let's I want to understand. So this policy map one, the percentage wise, which is the percent 10, then 23, then 15. What are you basing it on? Is it like 100% and you're dividing it or something?
Always this will be 100%. So when we'll go and configure this over SD-WAN, you will see that you have to give this 100%. Suppose if this is 10, 23, 15, 19, 5, 3, automatically the remaining will be 25. So let's add this, say 10 plus 23, 33,
Yes.
33 plus 15. Suppose this is 35 plus 15. So that will be 50 minus 2. So suppose this is 50. I'm adding this roughly 50 plus 20, 70, 70 plus 5, 75, 75 plus 3, 78, and then 25. Roughly this is 100, means this is 100.
Okay,
Bandwidth is
so
100 and you are dividing it. Yes.
okay, so yeah, so in this case, you are dividing in such a way that the one that you want higher will take like higher percentage. Like, so I'm looking at voice like this, you're giving voice 10%. So that means it's or maybe like a scavenger is the least. So you divide it, you give that one the least. So say I want to do this on my environment.
Yeah.
And I want to apply the policy. Is it
Okay, so you can think like this, that you have to think in terms of nature of business as well. Suppose this is call center. Suppose you are working for call center. In that call center, you have to give more bandwidth to voice traffic, right? Because your business is depending upon calls.
right?
Now, suppose I'm working on one enterprise network where my calls are less, internal calls are less. So what I will do, but still I want that my VC, my chancellors, my CEOs, whenever they are doing this conferencing or video conferencing, they should get some dedicated bandwidth. But that is not frequent. They are not doing that. So whatever bandwidth I have, according to that, I can fix 2%, 3%, 4%. But if it is a call center, I have to give 90%. Right? So it depends upon the nature of business. Now, for example, in my organization, if I have to give 50% to the TCP based traffic or web based traffic, so in that case, I have to give that much percent. So this QoS configuration that we have for organization, it is not like one time. You have to change the setting. As per the traffic requirement, it should get changed. The numbers should get changed. Okay, so now in this this is not full configuration. In this configuration, you can see that voice we are giving some bandwidth percent, right? And then you will see that in the critical data section, we are putting random detect DSCP based. Okay, so if you go to slide number 1, you should understand this, that in QoS we have different type of mechanism. So in QoS, we have classification and marking, and then we have some sort of queuing and dropping. So this queuing and dropping is something that it has different type of mechanism. Dropping mechanism means tail drop. So if it is non-critical data, if bandwidth is not there, use the method called tail drop it. Now suppose if it is a critical data and you don't want to drop, then in that case you can go and use a weighted random early detection, WRED. So what WRED is doing, that even before doing the actual drop, they will see that these traffic can cause problem in future. They will start dropping it before actual drop. That is weighted early random detection. That's the thing you can see here, that the random detect is DSCP based. So here you will get multiple options. If you go and type question mark, you will see options here that it's a tail drop or weighted random early detection drop or whatever. Means 3-4 options are there. So QoS is very important topic. You have to optimize the configuration. It's not like we'll go and simply do some configuration and it will work. You do the configuration like a standard configuration, and then you should go and optimize that configuration. Right?
Is this for the buffers only, or is this for the buffers?
This is for the
buffers.
buffers. Okay. So, so buffer is different thing. We'll see that how we are applying the shaping policy, policing and shaping. But this is something like priority. If we are giving some bandwidth %, that is priority. Buffering is different thing. Okay. All right. Now, other thing I told you earlier in this video, that we have two different types of QoS. One is software, one is hardware. Now you will see here in this diagram, suppose this is a big router, and if you see this diagram, you'll find that this portion is software-based QoS. Why? Because you can see different types. So how many queues are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. In different queues, you can see some queue has 2 packets, some has 3, some has 4, 5, 6, right? So here you can go and do all type of programming, algorithm, scheduling. You can see class-based weighted fair queue, or on top you can see LLQ or CBQFQ. These are the best queuing methodologies that we have. Either we can use LLQ. So if voice traffic is there, we are using either LLQ or class-based weighted fair queue. Now, you will see here that in the software-based QoS, you can go and apply all the mechanism, but once it is on the wire, so this is hardware queue. So here you don't have much thing to do. Here you can do some sort of, we'll see that if we can do some buffering here. So here you can do some sort of buffering, some prioritization, but you can't do much here. Okay, so this is a very important aspect related to QoS, that it's not simply creating the rule and applying it. We have to optimize this as well. Okay. All right, some other informative slides. So as you are talking about this shaping, so you can see that why we are using shaping, and we have discussed this earlier as well, that behavior of TCP traffic transactions, that at the moment they are hitting the peak, and if packet drops are there, they start retransmitting, and then your traffic bandwidth will go and drop to 50%. Rather than you can use some sort of shaping with some mathematical calculation. So you can do some sort of buffer as well, and then you can apply to the interface. So two mechanisms are there, polishing and shaping. Polishers will simply chop up the traffic, means it will go and drop the traffic, rather than in shaping, it will go and shapers typically delay excess traffic, smooths burst, and preventing unnecessary drops. So that's the difference between polishers and shaping. Both are congestion avoidance mechanism. So what are the mechanisms we have? At least you have two. One is congestion avoidance. One is congestion management. Okay, congestion management in QoS, congestion management is different thing. Congestion avoidance is different thing. So congestion is there. You can avoid it or you can manage it. So you have to check that the congestion avoidance, how we can do, congestion management, how we can do. Right. Now this is the last slide for today, and this is one very good example that will go and try to understand, and this will clear most of your doubt. And then I'll later on we'll go and see. So other headers are there. I will not discuss this today. We'll discuss it later on, but let's focus on this. Now you will see here in this diagram, very nice diagram here. You can see that you have one gig interface. In that gig interface, you have 150 Mbps bandwidth, subscribed bandwidth. And in that, again, it depends upon the nature of the business. So business is mostly using video or audio or critical data or business data, etc. According to that, the first task is this, that you do classification and marking. So here you can see that we are creating, this is called nesting of policy. So we are creating child policy and parent policy, and then this child policy we are calling inside the parent policy. And now you can see that Eric was asking that how we are applying it. You can see that we are applying to the interface. You can see that the direction as well, output. The best practice is this, that you can go apply to input and output, but in that case, some policy which is usable for input may be not usable for output. So you have option, you can create two different type of policy as well, like parent 1, parent 2, child 1, child 2, and you can apply to in direction and out direction in the same interface. That is also possible. Okay, so now let's see here that we have one policy whose class. So we are doing classification and marking here. We are doing classification. So what classes we have? We have class. You can see I am highlighting the classes here. We have these type of classes, and then finally we have some default class. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I missed something, 7, because 1 is default. So these classes we have, and for video, you can see 23%, for voice 10%. Like that, you have the percentage of bandwidth. That is the 100 means 150 here. 100% bandwidth utilization means you are using 150 Mbps of pipe. So that means that this will use 1.5, right? No, 15 Mbps. So this 15 Mbps is reserved for voice traffic. 50, why? Because 10% of 150 is 15. So 15% is like this. This is something I think 25. So 15 plus 15, 30, and then 3. That means this is something like 35 to 40% bandwidth reserved for video. Like that, you have reservation. Here you will see that for class data, we are doing some random detect as well. This is, so I told you two mechanisms are there. QoS management, and what was the other? Avoidance. So congestion avoidance, congestion management. Congestion avoidance. Now you think from yourself that with which particular mechanism we can do and avoid the congestion. So this is congestion avoidance mechanism, means before even having the congestion, you will go and start drop, random detect, drop it. Suppose if I go and use tail drop here, by default I think tail drop is there, or weighted early random detection. So that will become congestion avoidance mechanism, right? Congestion management, this classification and marking is some sort of congestion management, because you are doing that just to avoid the congestion in future, right? But again, we'll see that checklist as well later on. We have more and more slides related to QoS. So we have one full-fledged class coming up, maybe after 2-3 days, related to QoS, related to different hardware, how we are applying the QoS. Now this entire class that we have done today is based on that, what is QoS, why we are using it, what type of different mechanisms, and their sample configuration. This is the sample standard configuration. Right. So far, if you have any question, please feel free to ask. Hello, everyone. I'm going to give you offer related to CCIE lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have SD-WAN full-fledged lab. Actually, this is complete CCIE Enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in CCIE exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular EveNG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SDWAN, you need to work on vEdges and the vManage. Release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCI exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA because in this EveNG lab, we don't have Cisco DNAC integration, and you can't do ICE lab as well because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCI exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide, how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCI exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCI exam. So what is the cost of this? Because I'm offering this for the students, so I put very little a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request. Let me write here, Ratnesh721 Kumar 721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EveNG software, or the file where you can go and practice your CCNA, CCNP, CCI, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCI, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, in CCNP, again, we know that we have N core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market. So you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching.